Good morning, everybody. So the first activity today is looking at finding all the factors of a number, which for most of you will be revision, so it's just something we're going to look at quickly. So supposing I want to find the factors of the number 8. So the number 8 can be made by doing different times table sums, and it's quite easy because we can very quickly list all the times table sums that have the answer 8. So we know that 1 times 8 equals 8, and we also know that 2 times 4 equals 8. So that means the factors of 8 are 1, 2, 4, and 8. And when we list the factors, we try and put them in order from smallest to largest. That's the sort of correct way of doing it. If we don't, it's not the end of the world, but it's good to do things correctly we can. So with small numbers, it's fairly straightforward because we just know the times table sums. Once we start getting into slightly bigger numbers, it becomes slightly more challenging, but we can still generally just use our times table knowledge. So if I try and list all the numbers that have the answer 16, I know that obviously 1 times 16 makes 16. We can always start with the 1 times table sum because every whole number is in the 1 times table. I know that it's in the 2 times table because it's an even number, so I've got 2 times 8. And I know that it's also 4 times 4, which is a square number. So when I list the factors here, I've got 1, 2, 4, 8, and 16. Notice that when I've got 4 times 4, I don't list 4 twice because 4 is still only one factor. So I don't write 1, 2, 4, 4, 8, 16. I just write 1, 2, 4, 8, 16. So I've now got the number 24, and I'm going to try and find how many factors are in the number 24. Now, again, I can start to use my times table knowledge, but we're now getting to the stage where I've got the risk that I might miss out a times table sum because I forget about it. So what I'm going to do is I'm going to list all the numbers from 1 up to 12. And the reason I'm going to stop at 12 is because that's halfway. There's no point in going on to the number 13 because I know that if I do 13 times 1, it's not going to make 24. And if you do 13 times 2, it's going to make more than 24. So I know it's impossible to have any kind of times table sum that has a number bigger than 12 in it. So now I can simply go through the numbers one at a time. So I look at the first number, which is 1. So we know that 1 is always going to be a factor, so it's 1 times 24. 2, well, I know that it's 2 times 12. 3, I know that it's 3 times 8. Notice that I really need to have very good times table knowledge to do this. 4 times 6. 5, well, I know that 5 times 4 is 20 and 5 times 5 is 25, so it misses out 24, so 5 is not a factor. 6 is a factor, but of course I've already done the sum because I've done 4 times 6 up there. 7, not a factor because 7 times 3 is 21 and 7 times 4 is 28. 8 is a factor, but I've done it already up there. 9, not a factor because we can get 18 or 27, but not 24. 10, very obviously not a factor. 11, obviously not a factor because it's 11, 22, and then 33. 12 is a factor, but I've done it up there. And 24 is a factor, obviously, but I've done it with 1. So now, I know that I've got 1, 2, 3, 4, 6, 8, 12, 24. The good thing about doing it this way, apart from knowing that I've found all the answers, is if I look at the pattern, it actually goes 1, 2, 3, 4, and then back the other way on the right-hand side of the times table sums, 6, 8, 12, 24. So it's already got them in order without me having to think about it. So I'm going to do one more in the same way. So I'm going to do 36. So the way I'm going to do 36 is by starting at 1. So I'm going to list all my numbers from 1 up to 18, which is halfway to 36, and that's as far as I need to go before I start going too high. And again, I'm just going to look at the numbers in order. So I'm going to start with 1 times 18. So I'm going to start with 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So again here, I've listed all the numbers, 1, 2, 3, 4, 6, not 6 again, 9, 12, 18, and finally 36. Very quickly looking at prime numbers. So if I have the number 13, for example, I'm going to list all the numbers up to halfway. Now, obviously, when we get here, we notice that there isn't a whole number that's exactly half of 13. So just to be absolutely sure, I'll go to the next one, and then I'm going to list. So I've got 1, obviously, times 13. 2, it can't be 2 because 2 times anything is not going to make 13 because 13 is an odd number. 3, well, we go 3, 6, 9, 12, so it's not 13, so it's not 3. 4, it's not on the 4 times table. 5, clearly not on the 5 times table. 6, it's not on the 6 times table. 7, it's not on the 7 times table, and there's no point going any higher. So 13 has only got the factors 1 and 13. Which I can list if I want, although it's just basically the same as the times table sum. So that means that 13 is a prime number. So a prime number is a number that doesn't have any factors apart from itself and 1. So there you are. So we've looked at factors, we've looked at prime numbers. For most of you, that's just a bit of a revision activity. And later in the week, you're going to join these two ideas together and look at something called prime factors.